And so the new concept I want to introduce you to are called the getter and setter methods. Now, getter and setter methods are the proper way of interacting with properties in your object. Now, what we've done so far is we have, let's use this one. So if we had this CL car class, just like this, with these properties, and I won't add the methods to it, but let's say we have these properties. If I wanted to find out how many wheels the car had, I would say something like print, I got to create an instance first. My car equals CL car. There we go. Okay, so my car equals CL car. If I print my car dot int wheels, that's how I would normally interact directly with that property. I would find out how many wheels it has. If I wanted to change that, I would say my car dot int wheels equals 6. That's totally fine. I can do that. But here's a problem. I can just as easily do something like my car wheels equals 6. Now, think about this. Let's say I'm using this on my car fleet to figure out how many new tires I need to buy to replace all the tires on my cars. So I would take all of the int wheels and I'd add them all up, right? But what's going to happen when I try and add this to my total? I'm going to get an error because I can't add the string SIX to a number. So there's nothing stopping me from totally screwing up my whole program by changing that property from an int to a string by accident. And so this is why we need a setter method to prevent that from happening. And we use getter methods to do something similar, but when the data is coming out. So a setter method for CL car might look like this. Okay, so we have this. Oops, this is a setter. Setter. There we go. Setter method. A setter method might look like this, right? And this method, all it does is it takes an integer, and it's the end result is it's going to take that integer as a parameter, and it's going to set self.intWheels to that parameter. But what it does for us is it makes sure that two things are true. You look right here. Before it sets that parameter or sets that property to the number of wheels that you give it, it checks to make sure that it's a valid integer. It says, if is instance, int n, that's the parameter, and an int. So basically, if it's saying if this number is an integer and int n is greater than 1, because you don't really have a car or a vehicle with one wheel. I guess you could have a unicycle, I suppose. But we're forcing it here to be greater than 1. So at least 2 wheels, not 0 or 1. Then set it. And if not, you just say, sorry, I can't do that. So it's protecting our data. So let's implement that here. So I've got DEF, and typically I call setter and getter methods by a very standard set of names. I say set wheels, and then I'm going to say self and int n for the number of wheels I want to set it to. And so I say if is instance, and the first thing I say is int n, and then I say int for the type, and int n is greater than 1. Now, you have to do it in this order. If I take this and put it in front of is instance, I could get an error. If somebody puts a string here for int n, and I do this, I'm going to get an error. But if I say this first and I make sure it's an int before I check to see that it's greater than 1, then I'm okay. Because if it's not an int, it's going to stop here and not give me an error. As soon as it finds something that is not true, it will stop. Okay, so if is instance, then we're going to say self dot int wheels equals int n, else print you can't have, I could say this also. So I could reflect back whatever they said to them. You can't have 0 wheels, or you can't have the number SIX wheels. So that's my setter. And the setter makes sure it does all the checking for me. It checks to make sure that the data is in the right range, the right kind of data. It makes sure everything is good before it allows that property to be changed. And that's a lot safer than just directly changing the property. Even though we're allowed to do that and we can, we typically want to use a setter anytime we're changing that property from outside. Anytime we're changing the property from outside the object, we want to use a setter. And that allows us to make sure that things are in the right form. So that is a setter. Okay, and a getter should be here. There we go. That's a getter. I switched those two by accident. A getter just looks like this at its simplest. Okay, get wheels. All it does is return the number of wheels. What's the danger? What are we worried about? Not really anything, but here's the advantage. If I say def get wheels, and I use self, okay, that's okay. There's nothing really happening here. All it's doing is sending this number back out to the outside. So what's the point? Why would we do that extra work if we're not doing anything to it? Because if we set it up this way from the beginning, anytime we're getting information from our object to the outside of that object. If we use a getter, then we decide later that maybe instead of sending back when I get this out as an int, maybe I don't want that to be an int when I get that out. Maybe I want it to be a string that contains that digit. Then I can just change it on the fly in my object to what I want it to be on its way out, so that it's in an easier format. And I can change my entire program up by just changing it one time in my object. So using a getter feels a little bit pointless sometimes at first, but creating it this way when you want to create an object that talks to things on the outside is actually a smart strategic move. And so we always recommend anytime you have a property that's accessible from the outside, whether it's setting it or getting it, that you always use a setter and a getter instead of directly accessing that property. So that is the new information for today.